Okay, this video is going to show you how to do the first part 1 of the Parametric Problems assignment. There's only 2 problems. We're going to do the first one here, so hopefully you can get at least half the assignment right, if I can get this figured out. Okay, so before we start in on a part, the part's actually really easy to make. You've done the parts way harder than this before. But what we're looking at this time is parametric modeling. So instead of just putting in like a height of 5 inches and a width of 3 and then a whole depth of 2 and putting in actual numbers, you're going to put in equations all based off of a starting measurement. And if you come up here to manage, you'll see this box right here, f of x, which we know is an equation, and it says parameters. So if you click on that, you're going to see there's going to be a table here. And whenever you have ever done a part, it actually starts putting in parameters in here for the different lengths of things. And so we'll come back and look at this here in a little bit once we get started. But if you have your homework assignment, you're going to see the different dimensions and the equations we're going to use for those dimensions. The point of all the parametric modeling is that if you get done and you want to resize the entire part, you can do that just by changing one dimension, and everything else will be based off of that dimension algebraically, and it'd be really nice to be able to just shrink the entire part down by changing one dimension. So we're going to start by going back to sketch. We're going to start a new sketch. We're going to come in here, and you'll see that their dimension D0 is the overall plate depth, and it's going to be set at 3 inches. There's no equation for that. That's what it's going to be set at. D1 is overall plate width, and that's going to be a 5:3 ratio with the overall plate depth. So we're going to take DO times 5/3 to get our dimension, which will of course be 5 inches. Now, to begin with, we're actually just going to go ahead and put 5 inches in, and we're going to go and change that in the parameters table. So I'm just going to get a rectangle here, and I'm going to put this in here like so, and the overall plate depth, which is over here, we're going to be 3 inches, and then the overall plate width we're going to have be 5, and I'm just going to put those in there and hit return. I'll move this over here a little bit, and so once I've put a couple dimensions in there, I can go back to manage, click on my parameters table, and let's just check it out. So my DO was my overall plate depth, and I can change these to be other parameter names. In your second problem, you're going to actually change these to be like any variables. You could actually call it plate depth. You could call it that word, which is really a lot more helpful than actually D0 and D1 and so. But this is how they standardized it at the beginning. In this first problem, we're actually going to leave them as just D0, D1, D2, and so on. However, D0, my overall plate depth, was actually supposed to be 3 inches. So I'm gonna switch this around. I'm gonna have this be my 3, and this one, D1, is supposed to be 5, but it's not supposed to be 5. We're actually supposed to base it off of D0. So what I'm going to do for the equation, I'm going to do D0 times, which is an asterisk sign, 5/3. I'll put 5/3 in parentheses, and I hit tab, and you'll see that it gives you the nominal value is 5. So if D0 is my overall plate depth, 3 inches, that means D1, which is the overall plate width, is going to end up being 5 inches. But if I come and change this, see if I change this variable here, it'll automatically change the overall plate width, which is really nice. So I'm going to click done on that, and now it's fixed everything here, and you'll see it has an fx value, it has functions and stuff on there. And so from now on, we'll kind of do it a little bit differently. We won't go into the table every once in a while. We'll go in there just to check it out. So first thing I had to do is do a rectangle. I'm going to finish the sketch. I'm going to extrude that. Go to 3D modeling, extrude it. And how far out am I going to extrude it? Well, you'll see the plate thickness is D2. So instead of just putting in a value in here, I'm actually going to do D2 equals, and what is the thickness of the plate? It's going to be 20 times smaller than the overall width, which means 20 times smaller than D1. So I'm going to have D1 divided by 20. And I'm going to click the check mark, and that's going to put that in there, and it's as an equation. Just to check, let's go to Manage, look at our parameter table, and I had my D0, my D1 in there originally, and there's my D2. It's a thickness. Now, sometimes then there's going to be extra ones that are going to be put in. So automatically there's a taper angle, D3 that's put in there. Those are all at 0 degrees. We're not angling it up we're just zero. Most times it's going to be just 0 degrees. And you'll see in your chart that there is a D3 that's automatically put in there. Okay, so we can click Done on that. All right, let's see, what's next? So we want to put in, we have slot width as D4. Slot width location is D5. Slot depth location is D6. Good. So I think what we need to do here, slot diameter. Let's do, let's locate that slot. So the way I'm going to do this is let's go back to sketch. I'm going to start a new sketch on here, and I'm going to locate the center of that slot hole from this corner up here. So I'm going to do a rectangle, and I can go, let's see, I can do, well, actually I'm going to start from down on the bottom here, down here. And I can go D5 up and D6 over. So I'm going to do a rectangle. I'm going to actually do a construction rectangle here. And I'm going to come up here like this and just start it out there. And this first one, this value up here on the top, which is the width, would actually be my D6, right? So I'm going to put D6 equals, and what is it? It's 1/3 of the overall plate depth. So that's going to be D0 divided by 3. And then I'm going to hit Tab, and this one is going to be D5 equals, and what's D5 supposed to be? 4/5 of the overall plate width. So that'd be 4/5 of D1. So D1 times asterisk 4 over 5. And I can hit Tab on that. And that's good. So I can hit Return. And so now I've located the top kind of part of the slot there with both of those. Okay, I'm going to take construction off of that. And then, let's see, what do I need? I need the D4, which is the slot width. So I'm gonna, I'll do another construction, but I'll do a line, and I'll just come here, and I'll come down this way. And how far is D4? I'm going to call this D4 equals 1/2 the overall plate depth. So that'd be D0 divided by 2. And leave it at 90 degrees, return. Okay, all right, good. So now I got a slot width there. Let's see, what else do I need? We got D4, D5, D6. Good. D7 is the slot diameter. Okay, so what we're gonna do now is we're gonna go ahead and make our slot. So I'll hit the construction line off. Let's see, where is it at? Under rectangle, slot, there it is. I'm going to go from this one to this one. And then I'm going to come out, how much? Well, this is going to be my slot diameter, so I'm going to call this D7 equals twice the plate thickness. So that would be D2 times 2, and I'll hit return on that. And so now I have a slot. Good. Okay, so I can finish that sketch, because that's what I need right now, the slot. And then I'm going to extrude that. Go to 3D modeling, go to extrude. I'm going to actually cut it out, though. And how far? Well, the what does this be? This is slot extruded length, same as the plate thickness, which was D2. So I'm just going to do, and I want to call this D8, so this will be D8 equals D2. I can just do it that way. And do that. Okay, good. All right, let's take a break here and come up and manage and look at our parameters table. So we got a D0, a D1, a D2. D3 was the extra angle added in. D4, mine a little out of order. I did it a little bit backwards. D4, D5, D6. And then I got D7 was the diameter. I think, yes. D8 was the extruded length. And then when I extrude something, I have a D10, which is a degree there. And let's see, we don't want that. We want that to actually be, let's call that D9, because D9 is, it skipped D9 on me, it looks like. So I'm gonna change that to D9. Okay, good. So now I'll be able to start with my D10. Okay, so good, done. And then now I need to locate this hole. So the hole is D10 up and D11 over, it looks like. So I'm going to create a sketch, go back to sketch, start a sketch on here. I'm going to do a rectangle. Where's the rectangle? There. And I'm going to do construction. And I can come down this corner, come up here to locate the center. And the one going across there is D11. So I'm going to call that D11 equals, what is the whole depth location? 2/3 of the overall plate. So that'd be D0 times 2/3. And good. And then D10 equals, doing them a little bit out of order, but it doesn't really matter, 1/4 of the overall plate width. So that'd be 1/4 of D1. So I could do D1 times, I could do 1/4, or I could just do 0.25, which is good enough. And I'll hit return on that. Okay, and I got those. And then I need my hole diameter. So I'm going to take the construction off. I'm going to get a circle. I'm going to come right here. And I want this hole diameter to be D12. D12 equals, how wide's the hole going to be? It's going to be equal to the same as the slot diameter, which was D7. So that's good. Return. And there I got a hole. And then, of course, we're going to finish the sketch. We're going to extrude that. Go to 3D model. Extrude. We're going to cut it instead. And how far are we going to cut it? See, the whole extruded length is called D13. D13 equals, and it's going to be the same as the slot height, which was D8. Same as the slot height. That would have been D8, which was the same as D2. So we'll just do equals D8. Return. And then, of course, that probably added a D14 on there. So let's just go look at the, so that my part would be done. Let's go back up to manage the parameters and see what I got here. And D30, actually it had added on, it skipped the D14 again and put that taper angle as D15. Just to make sure it's exactly like the chart, I'll go ahead and change it to D14. Okay, and what you're going to need for this assignment for both parts is you're going to need to take a screenshot of this parameter table to show me that you got it all correct there. Click Done. And then what we want to do is we want to actually look at the eye properties of this part and to see if we did it completely correctly. And you're gonna record the volume and the surface area of this part. So I'm going to come over here, if you remember how to do that. Go to Part 3. I'm going to right click on it, go to Eye Properties, go to Physical tab. We'll go ahead and update it. I don't need to change it to any kind of material right now, but keep in mind the second problem is actually aluminum, so you will have to change that. I look here and I get a surface area of 33.250 square inches, and that is correct. That's the area you should get if you did this part correctly. That's what you should be getting and recording on your presentation. Your volume is 3.464 cubic inches. That's what you should get there. Okay. Now, what we can do then is, let's say I want to resize this. And instead of my overall plate depth at the very beginning, click on your parameter table. And instead of D0 being 3, I want to cut it in half. I want to cut it in half. Instead of it being 3, I want it to be 1.5. So this is where parametric modeling is crazy awesome. This is so very helpful. I can now just come in here to D0 and I can say I want this, instead of being 3, I want it to be 1.5 inches. Now you'll watch, if you watch all the equations, see there were lots of things that all just sudden changed. So the whole part, click done, the whole part resized, which is great. So I didn't have to go back. I mean, if I just do every single dimension, I don't do equations, you're done. You can't do it. You're going to have to restart the entire part. But if I can base everything off of one dimension, I can go change the one dimension, and everything will be resized accordingly. That's why parametric modeling is great. Now, if I come over and right-click on the part and I look at my eye properties again, physical, update it. Now, if you record your area, you'll see that it's 8.313. Okay, 8.313. Now, this is interesting. I hope maybe you can understand this. What did I do to length? That starting length, I cut it in half, right? Now, so what would that do to the overall area? Well, some people might think, well, I would cut it in half. No, area is length squared. So if you cut an area, or you cut a length in half, then the area will be cut in a fourth. It'd be a square of the half. If you cut the length in half, then you square that. Square a half is a fourth. So if you go and look at your original area, it was like 33.250. Divide that by 4, and now you have 1/4 of the total square area. Let's see if you can apply that to volume. So I cut the length in half. What would happen to the volume? Well, a volume is a cubic thing. So if you cut it into a half, if you cube a half, that would be 1/8. So if you take your original volume, which was 3.464, and you divide it by 8, you will now see this volume here at 0.433 cubic inches. So the volume of the part was cut by an eighth. It's an eighth the amount of space that it was originally, and that's because I cut the original length in half. Okay, so you need to record those areas and volumes, and then change that length, and then record the new area and volumes, and then the next part you're going to be kind of on your own. Good luck with that. And we're not going to use the D0, D1 things. You're going to actually create nice creative variable names for all those things. Hope that was helpful.